Hey guys, today we are going to talk about applying equations. This is chapter 8, section 3 in your textbook. So when we apply equations, the first thing we will start with is a word sentence. So for example, we have this word sentence: the sum of 3 times a number and 7 is 1 less than twice the same number. So it's very important that we use all of our skills that we have learned about translating expressions, and we use those skills very carefully so that way we can get a correct equation. Because if we don't have the correct equation, when we go to solve it, we're not going to get a correct answer. So just a reminder, the verb is one of the most important translated words that we have, because is the location of the equal sign. That is where the equal sign goes. Okay, and that equal sign is going to split up this word sentence in two parts. Okay, first we have the left side of the equation, which will be this part, okay, before the is. And then we will have the right side of the equation, which will be what's after the is, okay? So, phrase 1 before the is was the sum of 3 times a number and 7. 3 times a number and 7. Well, that translates to 3 times a number plus 7. So that's what's going to happen before the equal sign. Now it looks like it's the second phrase, and that was 1 less than twice the same number. Okay, so 1 less means we're going to subtract. We're subtracting from twice that same number. So it's actually 2n minus 1. Don't make the mistake of putting minus 1 plus 2n. That's not the same. Well, it is the same thing. But we make sure that we're reading it correctly, that we're subtracting the 1 from twice that number, 2n minus 1. All right, now that we have both phrases on each side of the equal sign, we can put it together with the equal sign in the middle. So again, this 3n plus 7 represented the sum of 3 times in a number and 7. And after the equal sign, the 2n minus 1, that represented 1 less than twice the same number. All right, so example 1. Find a number such that 5 times the sum of that number and negative 3 is 3 less than the opposite of the number. Okay, so again, locate your equal. Okay, and we look at phrase 1 and phrase 2. Phrase 1 says that 5 times the sum of that number and negative 3. So we're going to take the number and we're going to sum it or add it to negative 3. Well, adding a number to negative 3 is the same as subtracting 3 from that number. So that's how we got the n minus 3. And we took that sum, the sum of n minus 3, and we take 5 times that. So that's where the 5 is on the outside of the parentheses. All right, then we have our is, and then our second phrase on the right-hand side of the equal sign, after the is, says 3 less than the opposite of the number. So remember, opposite, you just put the negative in front of it, and that will give you your opposite. Okay, so negative n, indicating the opposite of n, and then we're going to do 3 less than that, which is where our minus 3 comes in. All right, now if you want to solve for n, what we're going to do, we distribute the 5, right? We distribute the 5. 5 times n is 5n. 5 times negative 3 is negative 15, equals negative n minus 3. I really encourage you to go ahead and finish writing everything out and have one complete whole set, know exactly where you are before you go on. If you're doing this and you're leaving this up here, you might forget to bring this part down, and then you're no longer solving correctly. So make sure that you finish the entire step, bring everything down that you didn't manipulate, and then move on to your next step. So now we want to get both variables on the same side, right? Let's say we want to get them on the left-hand side. So we need to take care of this minus n, or negative n, right? So we know that the inverse of subtraction is addition. So we add n to both sides, okay? And again, notice how this is one complete step. I brought everything down. And then 5n plus n gives me 6n. Still have my minus 15. I went ahead and brought that down. equals, and then my negative n and n cancel out just like we wanted it to, so leaving me just this minus 3, which just becomes negative 3. All right, now, to continue solving, this is now a two-step equation. So we take care of the addition and subtraction first. So to get rid of that minus 15, we add 15 to both sides. All right, giving us 6n equals 12. And our last step is to divide both sides by 6, giving us n equals 2. Next example, 25 more than 7 times the number is 46 more than 4 times the number. So again, locate your is, and then translate each phrase before and after the is. So the first one, we have 25 more than 7 times the number. More means we're adding, right? So we're going to have 7 times the number, 7x, and then 25 more than that, so plus 25. And that is the phrase before the is. Now the phrase after the is says 46 more than 4 times the number. So now we have 4 times our number, 4x, and we have more, which is add 46, giving us this equation here. All right, so if we were to solve this, right, we would get both variables on the same side. So we would subtract 4x from both sides. And then it looks like it already gave us the answer. So I will let you go ahead and try to solve this one on your own using what we learned last lesson in 8.2, variables on both sides. And I want to see if you can get x equals 7. That is the correct answer. So go ahead and try that. Make sure you can get x equals 7. If you can't, you might have to contact me. We can talk through it if you need to. All right, let's go on to our next example. The product of 4 and 3 less than a number is 15 less than 5 times the number. Again, locate your is right here. And we're going to look at each phrase. The product of 4 and 3 less than a number. Okay, so product, so that means multiply. 4, and then what are we multiplying? 4 and 3 less than a number. So we're multiplying 4 together with 3 less than a number. Well, this 3 less than a number, that's n minus 3. So we're multiplying 4 to n minus 3. This is what we have here, 4n minus 3, okay? On the other side, we have 15 less than 5 times the number. So we're subtracting 15 from 5 times the number, which gives us the 5n minus 15. Go ahead and see if you can't solve for that and get the correct answer. I'll go ahead and pause for you. All right, so if you use your skills that we have learned last week about solving variables on both sides, you should have got n equals 3. All right, so I want us to go ahead and review the steps in solving a word problem. This was on your last exam, and it's going to show up again and again because we will always be solving word problems in math. So just to review, step 1, represent an unknown quantity with a variable. This could be x, n, t for time, p for pizza, whatever you want it to be. Just pick a variable and stick with it. Step 2, when necessary, represent other conditions in the problem in terms of the variable. Step 3, identify 2 equal quantities in the problem. And step 4, write and solve an equation. And step 5, check your answer. Is your answer a reasonable answer? So let's take a look at this example. The sum of 2 consecutive integers is 173. Find the integers. So step 1 was to pick a variable. So we're going to pick x, and we're going to say x is your smaller integer, right? Remember, an integer is just a number that can be positive or negative. So we're going to let x be the smaller integer. Now, if the integers are consecutive, that means that the next integer is just 1 more than the smaller integer, which means that the larger integer is just x plus 1. It's whatever the smaller integer is plus 1 because they're consecutive, which means they come right after each other. All right, so we have represented it our two numbers. And look, it says the sum, which means that we want to add them together. The sum of those two integers is equals 173, giving us this equation. X, the smaller integer, plus x plus 1, the larger integer, is 173. So we can solve that. X plus 1 equals 173. We're going to combine our x's. We get 2x plus 1 equals 73. And from there, it's a two-step equation. We take care of the addition first, giving us 2x equals 172. Divide by 2, and x is 86. Now we have to go back and remember what x was. X was our smaller integer. Our smaller integer is 86, which means that the consecutive integer, the larger integer, is going to be x plus 1, which is 87. So we found our two numbers. They are 86 and 87. All right, next example. Find 3 consecutive odd integers such that 3 times the third is 2 more than 5 times the first. So this is a little confusing, but let's just think about what it means. Consecutive, which means they come right after each other. Odd. Odd means that even though it's consecutive, it's not going to be the number right after, because if you pick the number 1, the next number would be 2. 2 is not an odd number, so you need to pick 2 after 1, which would be 3, right? And then you're not going to go 1 more, you're going to go 2 more, so you get 5. And you're going to keep adding 2 so that way you still have odd numbers. So keep that in mind. We're going to let x be the smallest integer again, but the middle integer is not going to be x plus 1 because that would be even. We're going to let it be x plus 2 to make sure that it's the next odd consecutive integer, which means that instead of adding 1 more, the third integer is going to be x plus 4. So we added 2 twice to give us that last largest integer. So now we know we have our variable here, and then we did step 2, which is we represented other unknown quantities using our variable. So we had the next consecutive odd integer was x plus 2, and the largest x plus 4. All right, so now that we have represented our unknowns, now we kind of have to translate the phrases. It says 3 times the third one. Remember, the third was the x plus 4. So we get 3 times x plus 4 which is our equal, 2 more than 5 times the first. So our first integer was just x. So 5 times the first was 5x, and we have 2 more, so we added 2. So now we have our variables on both sides equations. So the first thing we want to do is take care of the parentheses, right? We had to take care of parentheses before we can start manipulating. So we're going to use the distributive property. 3 times x is 3x. 3 times 4 is 12. Okay, and that's how we get there. Now we go ahead and bring everything down so we have a fresh new equation to do our next step. Okay, now we're going to get the variables on the same side. For this one, we're going to go ahead and just pick the smaller term to get rid of, and the smaller term is 3x. So I'm going to subtract 3x from both sides. And when I do that, I get 12 on the left-hand side, and I'll get 2x plus 2 on the right-hand side. Now I have a two-step equation. So I'm going to subtract 2 from both sides, giving me 10 is equal to 2x, which means if I divide by 2, x is equal to 5. Remember, that's not the entire answer because we were trying to find 3 numbers. And x equals 5 is just that first number. And remember, it's the 3 numbers that are consecutive odd numbers. So if you think about it, that should be 5, 7, and 9. But let's just make sure that it works for what we picked to represent those unknown. Remember, we let the next consecutive odd number be x plus 2. Well, if we plug in 5, we get 5 plus 2 is 7, which is what we wanted, right? We said 5, 7, 9, so that worked. Now, our last number we said represented with x plus 4. So if we plug in 5, we get 5 plus 4 is 9, which checks because we get 5, 7, 9, 3 consecutive odd integers. All right, next example. We have a ship traveling at 20 knots, and knots are just the nautical miles per hour. So kind of like when we drive, we get miles per hour. This is nautical miles because the ocean isn't like a road, right? So we want to know how long will it take to travel 55 nautical miles? Well, we had to think about, well, how do we get our speed, right? Well, we get our rate times our time. Well, hold on, rate times our time equals our distance, right? How fast we're going, our rate, times how long we've been going, our time, gives us our distance. So this is a formula, a distance formula. Rate times time equals distance, okay? Well, the ship has a rate of 20 knots per hour, so that's our R, okay? And it wants to know how long, which means we need to figure out T. And it tells us that it traveled 55 nautical miles, which is our distance, our 55. So here we have 20T equals 55. Now to solve for time, we divide both sides by 20, and our T is 2.75 hours, 2.75 hours. So now we check, does it make sense that a ship traveling 20 knots and they travel 2.75 miles, do you think they have gone 55 miles? Well, if we think about it, 2 times 20 is about 40, right? And we have that 0.75. So yes, that kind of makes sense that we would have 55 nautical miles if we were traveling at a rate at 20 knots for 2.7 hours. So it does make sense. Next example, we want to know what is the speed of the wind if a plane capable of flying 400 miles per hour takes 3 hours to travel 1,050 miles into a headwind. Well, this is where, resistance come into play, right? If you have a plane who can go 400 miles per hour and it's taking them 3 hours to travel 1,050 miles, how long should they have taken? If there was no wind and they were traveling 400 miles an hour and they were flying 3 hours, they should have gone 1,200 miles, right? But they didn't. They only went 1,050, which means there was some wind. There was some wind coming up against them, slowing them down. So we want to know, well, what is the speed of that wind? How fast was the wind going to make them slow down? Because if we know that, then the next time the plane is flying, we can tell them, oh, it's going to take you this long because of this wind. So it's kind of important, especially in airports, right, to get the estimated time of arrival. So let's go ahead and we're going to start with the thought that rate times time is equal to distance, right? But our rate is being affected. We have the rate of our plane, but we have to take whatever our rate of our plane is and subtract the rate of the wind, right? The wind is going to subtract from the rate of the plane. So now we have R minus W times T equals D, okay? So we know the rate of the plane was 400 minus the rate of the wind, which is what we're trying to solve. The time, they took 3 hours, and the distance was 1,050. So now we're going to solve for W to figure out what was the rate of the wind. Okay, so first distribute, right? 3 times 400 is 1,200. 3 times negative W is minus 3W. Then we bring everything down equals 1,050. All right, now we have a two-step equation, right? So we need to get rid of this 12,000. We subtract 12,000 from both sides. And we get negative 3 is equal to negative 150. Make sure that you're watching your signs, right? 1,050 minus 1,200 gave us negative 150. Now we divide both sides by negative 3, and we find out that the wind was 50 miles per hour. 50 miles per hour. Next example. Luke and Andrew paddled their canoe 22 miles down the river in 4 hours. If the river's current averages 1.5 miles per hour, what is their average rate in still water? So remember, rate times time is distance. But if you're in a river and there's a current, that current is making you go faster. So you're going to take whatever your normal rate is, the rate in still water, and you're going to add the rate of the current. Okay, so we get the rate that we normally go in still water plus the current, because we're going with the current. It's adding to our rate. Now, if we were traveling upstream and fighting that rate, we would subtract C, right? And there's going to be problems like that too. But for right now, for this example, we're adding it because they're going with the river, down the river. Okay, times T equals our distance. So same formula, we're just getting to make ourselves go a little faster, right? So let's fill in our unknowns, right? We know that the river's current was 1.5, so our C is 1.5. We know that their time was 4 hours, and we know that they went 22 miles. So we need to solve for the regular rate, the rate that they were going in still water if there was no current, okay? So we distribute that 4. 4 times R is 4R. 4 times 1.5 is 6, equals 22. I've got a two-step equation. We're going to subtract 6 from both sides. We get 4r equals 16. We divide both sides by 4. And we get the rate of 4 miles per hour. That's how fast Luke and Andrew would have been going if they were in still water. Still water. All right, so your turn. You're going to do 8.3, number 2 through 6 evens. It's due in class along with your video notes. And thank you for watching.